Welcome back, class. Today we're going to talk about ionic bonding, the worksheet that we had done, or I had assigned to you before the break. And I want to go through just a few things about that. And the reason why is so we can all kind of stay on the same page for chemistry. And of course, I do enjoy doing these videos, and the reason why is because I like giving you a lot of information to help you succeed. And so, let's go through some things here. Ionic bonding worksheet. It says draw the valence electrons on the beginning atoms here. Draw the arrow showing the electrons being given from one atom to another, and draw the resulting ions on the right side. So, let's go through a few things here. The potassium atom versus the chlorine atom. Now, a potassium atom, if I check a periodic table, potassium's right here. Now, we can see that is in group 1, right? So again, think about it. Group 1, it has one valence electron, right? Boom, right there. And if I look at chlorine, that's chlorine, right? Yeah, it's chlorine. Chlorine is in group 7. You can guess, right? It has 7 valence electrons as a result. Now, that means we have to draw out 7, right? 1, 2, 3, 4, 5, 6, 7 valence electrons. Now it says draw the process, right? Draw the arrow showing the electrons being given from one atom to another. Now that's the thing here. What do we do? Well, what's going to happen is that chlorine needs to get to 8, right? And potassium wants to give that 1 to chlorine. And so we're going to show that process occurring right here, right? It's going to transfer its electron onto chlorine, and boom, now we have that arrow showing the electron being given from potassium to chlorine. It says draw the electrons with the resulting ions, so on the right side. So on this side, we're going to have 8 electrons on chlorine. 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons on this one, but none on the outer ring for potassium. Now, it's going to ask us what's going to be the charges of each, right? If I lose an electron on potassium, if I lose a negative charge, I'm going to become more positive, right? So, I'm going to be more positive by 1 electron, right? Because I lost 1. And chlorine gained that 1, right? Chlorine gained a negative charge, right? It gains 1 more negative, so it becomes negative by 1. So you have potassium plus 1, chlorine minus 1. Formula KCl. You just add those two together, right? Potassium, chlorine, and since we have plus 1 to a minus 1, right? They even out the charges, they're going to cancel out, become neutral, and now it's just KCl. What's the potassium, what's the name of it? Well, let's take a look right here. Potassium and chloride, right? So it's going to be kind of hard for me to write it out on pen or on mouse, but the answer is going to be potassium chloride. We add those two together. Potassium chloride. Now let's deal with this one down here. Magnesium and oxygen. Let's take a look. Where's magnesium at? Right here, right? Magnesium is in group 2. And so, you can guess, it has 2 valence electrons. Boom. And oxygen is in group 6. Shout the answer out for me. Yes, it is 6 valence electrons. So, 1, 2, 3, 4, 5, 6. Again, always make sure to add 1 on each side, even though it doesn't really look symmetrical. Add 1 on each side first, and then fill them up, right? I kind of left these sides open just so I can show you what's going to happen. Now we have to describe what's going to happen, right? Draw the arrows for the electrons being transferred. As we can see, oxygen has 6, but it needs 2 more to get to 8 for the octet rule. And magnesium wants to give them those electrons, so it's going to go 1 right there, and 1 right there. Now, it's going to ask us what's going to be the charges of both, right? Well, if I lose 2 electrons on magnesium, losing 2 negative charges, right? If I lose negatives, I become positive. Am I losing 2 electrons? I become a +2. And if I gain those electrons, I'm going to become a -2. Now, what's going to be my formula? Well, as we can see, we have a +2 and a -2. Right now, if I add them up, they're going to cancel out. And so my formula is just going to be simply MgO, magnesium and oxide, right? My name is going to be the combination of these two, magnesium oxide, and you can write that down there. All right, now let's do this one here. So there's a lot more on this page, right? And it's for good reason. Now, let's show a few things. Let's see first off where aluminum's at and where sulfur's at. Aluminum is in group 3. And as you can see, it would have 3 valence electrons as a result. And sulfur is in group 6. It has 6 valence electrons as a result. 3 and 6. So we got some funky numbers happening here. Let's first draw these out. 1, 2, 3, 1, 2, 3. Alright, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Don't do what I just did there, right? Because if I'm putting too much on one side, I may not get the other sides, right? So always put 1 on each side first. There we go. Again, we have to kind of show how or where those electrons will go. And so let's just first get it off right here and then. Let's start with aluminum transferring its electron onto sulfur here, and aluminum transferring its electron onto sulfur here. Okay, well we have this one more kind of hanging over here. Let's give it to this one here, right? Now aluminum's going to also, this other aluminum's also going to donate its electron to this sulfur. And so these two sulfurs are satisfied. And now we got to finish up the last one here. And boom. A lot of arrows showing here, but we can kind of see the same process occurring, right? We can give these electrons away to sulfur. And as a result, we have a new charge for each of them, right? Aluminum lost 3 electrons, so it's going to be a +3, right? All metals have positive charges. Now, with sulfur gaining those electrons, -2, right? Now take a look at this here. If I add +3 to +3, I have +6. And if I add all these -2's up, -2, -2, -2, I have -6, right? And so as a result, it's going to be a neutral charge. And so that's the good thing about this diagram here. It kind of shows us how much we really need to make sure that it's a neutral charge. And so my formula is going to be, well, I have 2 aluminums and 3 sulfurs, right? We just have to add them up as we see them. Al2 S3. And so we have 2 aluminum, 3 sulfur. Formula is going to be Al2 S3. My name, again, aluminum. We keep the name aluminum, keep the metal name. And then the non-metal is the IDE ending, right? Aluminum sulfide. That name goes here. Hopefully that makes sense. Hopefully that all kind of clears it up for you. I will make another video on the crisscross method for you. If you have any questions, please let me know, and thanks for watching.